You want to write an explicit formula for this sequence. When n is 1, we get 36,000. N is 2, we take 1.03, multiply by a previous term, and then add 36,000. When n equals 3, we take 1.03, multiply it by the second term. So this second term right here is founded in here. And then added 36,000. And then when n equals 4, we take the previous term and do 1.03 times that previous term, add it to 36,000. And then you just keep repeating that. Now, just by looking at this, we only see two numbers. We see 1.03 and we see 36,000. So we know that 1.03 multiplies by itself and it multiplies by 36,000. So if I were to rewrite this, we have n equals 1 is 36,000. N equals 2 is 1.03 times 36,000 plus 36,000. N equals 3. This one, we're going to distribute the 1.03 to both 1.03 times 36,000 to get 1.03 squared times 36,000 plus 1.03 times 36,000. And then finally we have the 36,000 outside, and that's not being multiplied by anything. Next, for n equals 4, we have 1.03 multiplying this entire inside. So what we said from the beginning was the formula is take 1.03 multiplied by the previous term and add 36,000. So you can, if you want to simplify this, or you could just take 1.03, multiply everything here, and then add 36,000. So that's probably an easier. And if you want, you can, come up with a recursive formula, which will just be 1.03 times a sub n minus 1 plus 36,000. So take your previous term, multiply by 1.03, add 36,000. That's all we're doing. And then if you want n equals 5, just multiply everything by 1.03, and that will just increase the exponent of 1.03 by 1. And then at the end, we will add by 36,000. Okay. Now, the next step, I'm going to rewrite n equals 1 as follows. I'm going to say, well, it's going to be 1.03 to the 0 power times 36,000 plus 36,000. Now we want to make a connection between the exponent and n. Notice when n equals 1, the exponent here is 0. When n equals 2, the exponent here is 1. When n equals 3, this is 2, this is 1, and then technically there should be a 0 over here as well as these guys. These two. And then when n equals 4, we go down to 3, 2, 1, and then technically again this is a 0. This is 5. We go minus 1, minus 2, minus 3, minus 4, and then to 0. So we can come up with a formula now. Let's say for n equals k, we're going to do 1.03. That's going to be k minus 1 times 36,000 plus 1.03. Now we're going to subtract 1 from k minus 1 to go to k minus 2. And then you'll go to k minus 3, k minus 4, etc. all the way down to when you hit, well, it'll be 1.03 to the first power times 36,000, and finally we'll have 36,000. Now we can factor the 36,000 from this formula. So we have 36,000 times, and then I'm going to go right to left. So I'm going to factor out the 36,000 from the right. So I have 1 plus, and then 1.03. And the exponent is going to keep going up by 1. So it's going to be all the way up to 1.03 raised to the k minus 1 power. And now I can use the geometric series sum for, I guess, a finite geometric series sum, which is the first term minus the omitted term divided by 1 minus the ratio. Okay, so I have 36,000. The first term here is 1 minus the omitted term is the term that comes after this one. So this is the last term, so we go 1 more, which will be 1.03 to the k. And that's 1 minus, the ratio is just 1.03. Now I can simplify this. I have 36,000. And I'm going to, let's see, subtract 1 minus 1.03, and then I have 1 minus 1.03 to the k. And I'm going to multiply basically by negative 1 top and bottom. So what happens is this becomes a positive, and then I flip the negative. I flip the signs. So here 1.03 to the k is negative. Now it's positive. 1 is positive. Now it's going to become negative. Multiply that by 36,000. So now I have to do 36,000 divided by 0.03. Well, if I do 36,000 divided by 3, that's 12,000. But I have to move the decimal twice. So it's going to be 2 extra zeros. And then I'm left with 1.03 to the k minus 1. And this is our final answer.